Ensuring an airtight seal of the sampling point is necessary because ambient air from inside the building can leak into the sampling device and bias the results. For this presentation, we will be illustrating the water dam method. Equipment needed for this test includes a 2-inch diameter or equivalent collar, non-VOC putty, DI water, and a water extraction device such as a turkey baster or wet vacuum. First, seal the collar to the floor with non-VOC putty around the sub-slab point. Attach the sampling train to the sub-slab sampling point, add water to cover the sub-slab point and sampling train connection point, and mark the water level within the PVC collar. Observe the water level for any sign of water loss through the sub-slab point or sampling train connection. The water dam should remain in place throughout the sampling process to ensure the seal is not compromised by agitation. If the water level drops, the seal is compromised and sampling should not commence until the seal is reset and reconfirmed to be airtight, or a new sub-slab sampling point is installed and leak tested. A shut-in test is used to determine the air tightness of the sampling train fittings. If the sampling train fittings leak, ambient indoor air can be introduced during sample collection, biasing the results. To conduct a shut-in test, connect the vacuum gauge to the sampling train between the sub-slab probe and the sample collection device, also known as a SUMA canister. Make sure the valves to the sub-slab point and SUMA canister are closed. Use a graduated syringe or hand pump to remove air from the sampling train. Remove enough air from the sampling train to create a vacuum of 25 inches of mercury as read on the vacuum gauge. Observe the vacuum gauge for a minimum of 5 minutes for any decrease in vacuum. If a decrease in vacuum is observed, release the vacuum, recheck and tighten all fittings, and redo the shut-in test until sustained air tightness is observed in the sampling train over the required time frame. To ensure the sample collected is representative of the soil gas present below the slab, purge the sample train and sampling point prior to sample collection. The purging sequence is as follows. Position the manifold valve to allow vapor to flow from the sample location to the closed evacuated canister to fill the sample tubing. Close the manifold valve to the sample location and use the syringe to pull vapor from the 4-way valve to the closed evacuated canister to create a vacuum, thereby pulling a total of 2 volumes of vapor from the manifold valve to the closed evacuated canister. With the manifold valve closed to the evacuated canister, position the manifold valve to allow vapor to flow and use the syringe to pull a minimum of 2 sample point and tubing volumes of vapor, or the volume directed in the site-specific work plan from the sample point. Remove the syringe from the 1-way valve and discharge vapor from the syringe away from present personnel. With the manifold valve open to the evacuated canister, open the SUMA canister valve, or connect the SUMA if using quick connections, to begin sample collection and record the initial vacuum pressure on the vacuum gauge and the start time of the sample collection. Observe the progress of canister filling until a vacuum reading between 5 inches of mercury to 1 inch of mercury is achieved. Then close the valve on the SUMA canister. Do not let the vacuum reading on the canister go all the way to 0. Record the sample collection end time and final vacuum reading on the chain of custody and logbook. Connect a field instrument, such as a photoionization detector, to where the SUMA canister had been connected. Open the valve and measure the organic vapors present in the sampling point. Record the field instrument readings in the logbook and on the chain of custody record. Upon completion of sample collection, the sub-slab sampling point must be airtight sealed either permanently or temporarily to prevent vapor intrusion into the building. For more information regarding sub-slab sampling, please contact the Minnesota Pollution Control Agency.